All right, now we're ready for part two. I put part of this problem in the graphing calculator here. There we go. There's graphed. We got to find the two intersection points. I bet they're -3 and 2, but we'll just see. So we'll go second trace. We got to see where they intersect 5. The first curve, I'm already right over there on the right side, so I'll push enter, enter, enter quick. And that's at 210. So lower curve, upper curve, intersects at 210 here. Then we'll do that again. Second trace, intersect 5. We'll go to the left-hand side. Go enter, enter, enter. -3, 5 is where they intersected. So now I got to go the top curve minus the bottom curve. Okay. What's my top curve? Well, it's this one. Bottom curve is this one. How do I know that? Because of my y-intercepts. So we go top curve minus bottom curve. So turn this off. Turn this off. So it's y1 minus y2. Turn that on. I'm going to graph that one. It's going to make an upside down parabola. I'm going to go second trace the integral, number 7, from -3 to 2. It's going to shade it in. It's going to give me that. I'm going to math, change it into fraction, please. 125/6. Easy peasy lemon squeezy. Area of the region between these two graphs. Okay. Well, 4 minus x. What does 4 minus x look like? 4 minus x. So 4. So if we go 1, 2, 3, 4. Equals 5. So we have a line. G of 5 is a horizontal line here. X equals -6 to -2. Whoa, I'm not even in the right ballpark here. All right. So we're going from -6 to -2. So boom, boom. 1, 2, 3, 4, 5, 6. So 4 over a -6 is a -2/3. So 1, 2, 3, 4. So we're at -2/3 at -6. We're at -1 at -4. I know that. At -2, 4 over -2 is -2. And then we're going all the way up to the line x equals 5. So it kind of looks like that. That's what we got going on. All right. So top curve minus bottom curve would be the integral of 5 minus 4 over x from -2 or -6 to -2. So if we integrate this, it'd be 5x minus 4 ln of x from -6 to -2. And then we get -10 minus 4 ln of -2 minus -30 minus 4 ln of -6. So -10 minus a -30 is plus a positive. We got a positive there. All right. So -10 plus 30 is 20. And then negative 4 ln of 6 plus 4 ln, or negative 4 ln of negative 2 plus 4 ln of negative 6. When you're, let's change the order of those two, because then let's put the positive in front. So let's go 20 plus 4 ln of negative 6 minus 4 ln of negative 2. All right. So then when we're subtracting, we can make a fraction out of it. So it'd be 20 plus 4 ln of negative 6 divided by negative 2 is a positive 3. So 4 ln of 3 would be 20 plus ln of 3 to the 4th power. 3 to the 4th is 3 times 3 is 9 times 3 is 27 times 3 is 81. Hey, this answer right here. Okay. Fun with math. Math is fun. All right. Let R be the region enclosed by x equals negative 2 and y equals 1 and y equals 3 and the curve y equals that. We're going to rotate it about the line x equals negative 2. We're rotating around a vertical line. It is the disk method around a line that is not an x-axis or y-axis. So we basically subtract the difference between those two. So the disk method is pi r squared. So it's pi integral. And we have to go from here to here because it's around a vertical object. So it goes from 1 to 3 of this line minus this line. So it's the square root of x plus 2 minus 2 squared. Okay, exact terms of pi. Dang it. Dang it, dang it, dang it. That's not a very nice one. Minus a negative 2. All right, this line minus a negative 2. So it goes plus positive. But that's just not that nice. Because it'd be nice if we could square this before we did that. But I don't think we can. So, exact answers in terms of pi. Well, let's go math 9 from 1 to 3 of second square root of x plus 2, get out of there, plus 2x. Enter. Yeah, that's just ugly. Math turned to fraction. Yep, dang it. I knew that would happen. They wanted exact terms of pi. That's not nice of them. Not nice at all. So it's pi, the integral from 1 to 3. If we square this out, it would be x plus 2 plus 4 square root of x plus 2 plus 4. So it'd be x plus 6 plus 4 times the square root of x plus 2. Or that is really to the 1/2 power. All right, integrate. So then it's x squared plus 6x plus the integral of that is x plus 2 to the 3/2 and then divided by 2/3. So it's 2/3 of 4, which is 8/3. Yeah. From 1 to 3. So that's pi. And then so it's 9 plus 18 plus 8/3 of 5 to the 3/2 minus Birschbach, you're so stupid. Thank the Lord I started using my brain because I knew this couldn't be the answer. What did I do wrong? Well, this is what I did wrong. We're going around a vertical, so you got to get x alone here. So you square both sides, so it's y squared minus 2 equals x. There we go. Woo! Much better, much better, much better. So we are going to integrate from 1 to 3 of y squared minus 2 minus a negative 2, and all that is squared. So we go plus a positive 2. So minus 2 plus 2, that cancels. So it's the integral from 1 to 3 of y squared squared, which is y to the 4th. So the integral from 1 to 3 of y to the 4th, which is 1/5 y to the 5th from 1 to 3. So 3 to the 5th power is 243 over 5 minus 1/5. Because if we put in a 1, there we go. Yep, that's right. So it's 242 pi over 5. Much better answer than what we were getting before. All right, we're almost done here. Total number of subscribers he has his video page is that. At time equals 8 weeks, he has that many subscribers. How many does he have by week 20? So it's the integral from 8 to 20 of 21 minus 2t. And then he started out with 120 at 8 weeks. So we have to add that on to it. So it would be that. The average value of that function, okay, average value of the function is the integral from 3 to 5 of 6x squared plus 8. Do that in the calculator quickly and easily. Math 9 from 3 to 5 of 6x squared plus 8 dx. Enter, and you get 212 is the average value. And then particle that. How far does the particle move from that to that? That's the integral from 1 to 4 of 3 square root of t. So it's 3 times the integral of 1 to 4 of t to the 1/2, which is 2/3. 3 times 2/3 of t to the 3/2 from 1 to 4. Well, the 3's cancel. So it's 2 times 4 to the 3/2 is 8. 1 to the 3/2 is 1. So it's 14 units. Last one. Whoop, second to last one. Particles position at time equals 7. So it's 3 plus the integral of t squared over sine squared of t plus 2 from 3 to, oh, no, from 2 to 7. So it's 3 plus second, not second, it's math, 9 of 2 to 7 of t squared divided by the quantity sine of t squared. Oh, come on, Bierschbach. Squared. Need an extra parenthesis right here. Plus 2. So that's sine squared of x, which is sine x squared, plus 2, t squared up top, dx, integrate, solve, 58.58. And lastly, we are region basis solid cross section, perpendicular rectangles. So if they're rectangles with the height of this is the height. Okay. And then you have to take top minus bottom. Top is this, bottom is this, which is, I'm sure, 3 minus x squared because it's the same for each. And if it's perpendicular to the x-axis, you start at 0 and you go to 3. So it's 0 to 3. So it's 0 to 3 of that. All right. So Khan Academy test gets started now. You have till next, well, you have till you get back from Easter to get it done. How about that? So get it done by the time you get back from Easter, and you think, oh, that's a long time from now. Well, no, it's going to kick your butts. So work on it. Start this weekend. Start today. All right. Have a happy snow day. Bye.